Hey there and welcome. Ever been at the beach, you get a little ocean spray on your lips, and you just kind of wonder, why is this so salty? It seems like such a simple question, doesn't it? Well, today we are going to dive in and get to the bottom of it. Seriously? Why is the ocean salty? It's a question you've probably asked since you were a kid. You'd think the answer is simple, the salt is just in the water. But no, the real story is so much cooler, and believe it or not, it starts hundreds of miles away from any coast.
See, the common assumption is that the ocean was just born salty. But the secret to its saltiness doesn't actually start in the water at all. The real story begins somewhere else entirely.
It's in the rocks, on land. I'm not kidding. The salt in the ocean actually comes from rocks, sometimes way up high on mountaintops. How wild is that? The whole journey to a salty sea actually begins on solid ground. All right, let's trace this incredible journey. We're going to start our story way up on a mountaintop and follow these minerals all the way to the deep blue sea.
The whole thing really boils down to three simple steps. First, rain breaks down rocks. Second, rivers act like a delivery service, carrying the minerals. And third, the ocean is basically a giant collection bin. Let's walk through it.
It all starts with something as simple as rain. But here's the catch. Rain isn't perfectly pure water. As it falls, it absorbs carbon dioxide from the air, which makes it slightly acidic. Think of it like a tiny chemical key that, over thousands and thousands of years, slowly dissolves rocks and unlocks the salty minerals trapped inside. So, once those minerals are broken free from the rock, they need a ride to the ocean. And that's where the next part of our story kicks in. The rivers. It's time for a journey to the sea. Yep, you can think of rivers and streams as nature's massive conveyor belt. As they flow over the land, they scoop up these tiny dissolved mineral particles and carry them all the way from the mountains down to the coast. Okay, but wait a second. This brings up a really good question. One you might be thinking right now. If rivers are carrying all this salt, why don't they taste salty like the ocean? Well, there are a few reasons why rivers stay fresh. For starters, the concentration of minerals is so low, it's just too diluted for you to taste it. But more importantly, rivers are always moving. They're constantly getting flushed out with fresh rainwater, so the minerals never get a chance to build up. It's a one-way trip to the sea for that salt. And that brings us to the final destination, the Great Salt Trap. This is the real aha moment in the story, where all the magic happens. The key here is something we all learned about in science class: evaporation. When the sun heats the ocean's surface, the pure water turns into vapor and rises up to form clouds. But the salts and all those other minerals, they're too heavy. They can't evaporate, so they get left behind. Now, just try to imagine that cycle happening over and over and over again for millions upon millions of years. Rivers keep jumping in minerals, and the sun keeps lifting out fresh water. This process has slowly but surely turned our oceans into the massive storage tanks for minerals that they are today. So when we talk about ocean salt, we're not just talking about the simple stuff you sprinkle on your fries. Seawater is actually a much more complex chemical cocktail. Sure, the main ingredients are sodium and chloride, what we all know as table salt, but they're mixed in with a whole host of other minerals. You've got big helpings of magnesium, calcium, and potassium in there too, making it a truly complex mixture. Now, to really put this into perspective, get this. If you could somehow remove all the salt from all the oceans and spread it evenly across all the land on Earth, you'd end up with a layer more than 500 feet thick. That's like burying every single continent under a 40-story skyscraper made of salt. It's just a mind-boggling amount. So, this leads to one last question. If rivers are always adding more salt, why doesn't the ocean just get saltier and saltier until it can't hold anymore? Well, this is where nature's balancing act comes in. It's pretty amazing. You see, the ocean isn't just a big passive tub, it's a living system. For one thing, tiny sea creatures actually use some of those minerals, like calcium, to build their shells and skeletons. Other salt particles sink to the bottom and become part of the seabed, eventually forming new rock. And then, plate tectonics actually recycles those rocks back into the Earth's crust. It's a perfect, self-regulating system. So, to tie it all together, let's use the soup pot analogy. The rivers are constantly adding cups of water, each with a tiny, untastable pinch of salt. The sun is like the stove, boiling away just the pure water as steam. And the ocean? That's the pot itself, where all that salt it's left behind and becomes more and more concentrated over millions of years.
So there you have it. The salt in the ocean tells this incredible story of geology, chemistry, and biology all working together. And knowing about this ancient, delicate balance really makes you wonder, what does it tell us about all the other interconnected systems that keep our planet healthy? Definitely something to think about on your next trip to the beach. Thanks for joining me.